Welcome students. Let's talk about the next definition into the group theory, that is cosets. Let H be a subgroup of a G. We had already talked about the subgroups in the last lecture. So if you have not seen what are subgroups, then please go to the last lecture and understand what we mean by these subgroups. So let H be a subgroup of a group G and let an element A that belongs to G. Then the set obtained by performing the operation with all the elements of H with the element A is called the coset. And whenever the element is on the left hand side of the operation, then it will be denoted as the left coset, and if the element is on the right hand side, then it will be denoted by the right coset. So in the left coset, the element is always on the left hand side of the operation, and on the right coset, the element is always on the right hand side of the operation. So these are the cosets, and obviously both the cosets, either it is a left coset or it is the right coset, are the subsets of the group G. Now let's see an example what we can say. Let G be an additive group of all integers and H is a subgroup. So this is the G additive group of all integers. That means the operation is addition. From this group we have one subgroup, that is H. Again this is a additive additive group, and let's take some element from G. Let's take 0 which belongs to the, this is a the element 0 which belongs to G. Then if we'll perform this operation H plus 0, that means we are adding 0 in each element of the H, but this addition, the operation, the element is on the right hand side of the operation. So we can see if we'll write if we'll take this element minus 9, so performing minus 9 plus 0, we have this minus 9, right? If we'll take the next element as minus of 6, so now performing minus of 6 plus 0, we obtained minus of 6. So this is the result we are getting by performing the addition on all the elements of H with the element we have taken from the G, and thus we have the right coset. So this is the right coset. Similarly, we can also calculate the left coset. For that we'll have to do something like this. We'll have to keep the element on the left, then the operation, and then the subset. So if we'll take the same subset, then we'll perform 0 plus minus 9, then 0 plus minus 6, 0 plus minus 3, and just by performing this operation, the obtained set will be a coset, and that will be known as the left coset. That will be the left coset. Now let's talk about some properties of the cosets. These are the properties of the cosets. Let H be a subgroup of G and A and B that belongs to G. Then A will belongs to H whenever the A is the identity element of G. That is, A belongs to G and A will be the identity element of G. So this is the first property. The second property, AH will be equal to H if and only if A belongs to H also. In the second case, this is possible whenever the selected element from G also belongs to H. Then AH is equal to BH, or AH intersection BH is always equal to phi. AH and BH are always equal and their intersection is always phi. Both the cases are either or. Either AH and BH will be equal, otherwise the intersection of both will be a phi. That means it cannot be possible that some elements of AH are equal to some elements of BH and some elements of AH are not equal to the some elements of BH. Now the fourth property, that AH is equal to BH if and only if A inverse B belongs to H. So that is the inverse, if inverse is belonging to the subgroup H, then only it is possible that AH is equal to BH. So these are the properties of the cosets. So we can also see the proving the first property, that A is equal to AE, that belongs to AH. So where E is the identity. The second property, if E be the identity in G, so in H, then only AH is equal to H. That means AE belongs to H. So A will also belongs to H. If A belongs to H and H belongs to H, then obviously we will say that AH is the subset of H. Similarly, we can prove the other part also, that H is a subset of AH. And from these two conclusions, we can finally say that AH is equal to H. You can hold on the screen, pause the screen, and can read it through, and for any confusions you can clarify. Now let's talk about the normal subgroups. So a subgroup H of a group is said to be a normal subgroup of G if its left coset and right cosets are equal for all A elements belongs to G. So if its left coset and right cosets, are equal for all elements A that belongs to G, then we'll say that this is a normal subgroup. So this is the definition of the normal subgroup based on the definition of the cosets. Order of a group. What we mean by the order of a group? The number of elements in a group is called the order of the group. Very simple. The number of elements in a group is termed as the order of the group and is denoted by A of G. It can be a finite or can be infinite also. So this is the order of the group. That's it for the lecture. Thank you so much.